I'm very happy to talk to you about how you can use Securosys HSM in the context of AWS. I will start with a very brief introduction about the so-called Digital Sovereignty Pledge, which is a program at AWS, and then focus for the majority of my talk about talking about cryptography, about key management service or KMS, and then how XKS actually works. So this external key store feature that we have. And I will close my presentation by having a quick look at how the solution would look like with Securosys HSM. Now, the Digital Sovereignty Pledge is a program that we started in 2022, and it covers roadmaps or capabilities for data residency, granular access restrictions, encryption, and resilience. And for today, we will focus on one of those, the number 3, the ability to encrypt everything everywhere. Let's first have a very brief look at how digital sovereignty actually evolved at AWS. And this is a very rough timeline, not covering all the details. As I mentioned, the pledge itself was founded in 2022, and before and also after that, we made a series of announcements. And some of them include encryption. Some of them include other things like introduction of Nitro, for example, which is a technology that we use for virtual machines, fully in hardware. There's no DOM 0 anymore. Or also even very large things like the European Sovereign Cloud that is yet to come in Germany. XKS, or External Key Store, was actually one of them. And this will be our focus today. And the starting point for that was this. This is an excerpt, or the exact wording actually, from the Digital Sovereignty Pledge, the one that we announced in 2022. And it says, we commit to continue to innovate and invest in additional controls for sovereignty and encryption features so that our customers, and now it comes, can encrypt everything everywhere with encryption keys managed inside or outside the AWS cloud. And when we talk about encryption at AWS, we need to talk about Key Management Service, or KMS. So let's first have a look at this one. Here we see a very concise and clear definition of what KMS is. KMS basically powers encryption in AWS. It's a FIPS 140-2 level 3 certified service and integrated into more than 100 AWS services. And it's built in a way that is completely transparent, seamless, and easy to use for customers. So it abstracts all the complexity that might come with encryption and also configuration. And KMS integrates into IAM, or Identity and Access Management. So you have the possibility to define not just identity-based policies, but also resource-based policies. So how does it work? Well, on a high level, you create a key. It's crypto, you need a key. And to be honest, I'm lying a little bit here, because when you create a KMS key, you actually not really create a key. There will also be keys, but there will be a lot more keys than just this one. But since I want to focus on actually XKS here, I will not go into all the details on how it works internally. If anyone is interested, happy to talk about. For now, let's just assume we have a key. And that key is or can be used to encrypt, to decrypt, to sign, to verify, etc., etc. And you define the policies to control access to that key. And there will also be monitoring, data sent to CloudWatch or CloudTrail. And when a service uses encryption using KMS, it typically uses something we call envelope encryption. So we use a dedicated data key or a specific data key for a single piece of data encrypted in the service, and then that key is managed in a key tree, which on top actually is consolidated in KMS. So let's see how that works. And this is a very simple example here. So let's assume I upload an object to S3. S3 is our object storage. The first thing that happens is, and we see it on the top right, a customer calls the put object API. Now, the first thing that happens is KMS, or S3, sorry, S3 calls an API in KMS to create a data key. KMS creates a data key, as we would expect. And it returns the key in two versions, in an encrypted version and in a plain text version. In an encrypted version, using actually a derivative from a key that we store in KMS. Why does it do that? Because encrypting such amount of data in KMS would never scale. So encryption is handled by S3. So S3 encrypts the object and stores the encrypted object together with the encrypted data key on durable storage. The plaintext key is erased, and a plaintext key naturally was also erased in KMS immediately after it was returned. In a decryption operation, a user will call getObject. It's also an API. So S3 first loads the encrypted object and the encrypted data key from durable storage, sends the encrypted data key to KMS. Dear KMS, can you please decrypt that? Yes, of course I do. KMS returns the plaintext key. S3 can decrypt the object. User gets the plaintext object, and we're all happy. Now, I think I forgot something. If we look at the text that I have shown you, the one from the Digital Sovereignty Pledge, I actually missed something, because we pledge that are allowed with encryption keys managed inside or outside AWS. What I have just shown to you is purely internal. That's all AWS. So what happens if you want to manage your keys by yourself? Entering external key store, or XKS. XKS is a great example on how we delivered on the Digital Sovereignty Pledge. It's a full removal of root of trust from AWS. It's fully transparent. I mentioned in KMS there was always the goal to make it transparent and easy for you to use, and we wanted to do the same for XKS. It's flexible. You can activate or deactivate XKS on a key level. So per KMS key, you can define if you want to use XKS, yes or no. And that's the important thing, you not only own the key virtually, you own it physically, because it's not stored in AWS. And that can be helpful if you're facing according regulatory requirements, for example, that require you to have also physical ownership of a key. And with that, it actually acts as a stop switch or a kill switch, as we would say. Because if you pull the plug, you cannot decrypt the data anymore. So, and that's the last time we look at KMS, promise. KMS offers a few options. And the reason actually I wanted to show you this slide is on the left, on the left, you see what I showed, what I have shown in my initial slides. And you see XKS is actually, when we talk about customer control, it's pretty much on the right. The only option that you can use is don't use KMS at all. Like, don't encrypt your data or do client-side encryption. But that's not something we want to do if not absolutely needed, right? And so let's see how that works. Well, the basis is still the same. We have an AWS service and we have KMS. KMS is still in the game here. The AWS service can, for example, again be S3, as I have shown in the example. And again, our goal when we created XKS was we wanted to provide you the same seamless features and usability than when you use KMS. It shouldn't be complex to use encryption. Now there's two new things here involved, which is an XKS proxy and an external key manager. The external key manager is a HSM typically. And the proxy is basically a piece of software that translates KMS language into HSM language. Or in other words, to prevent you from having to dig into PKCS11 and stuff like that. So we looked at S3 without XKS. Let's look at how the same process works when you use XKS. And you see we have these two additional items, and I will not go into all of the details like the generate data key, et cetera, and what actually happens from the beginning, because we want to focus on what happens in this external key store. Step number 1. Yes, we still have a generate data key. So the AWS service called KMS, hey, please give me a data key. The data key is generated and encrypted using your KMS key. So far, no change to the process. Now come the changes. Now, instead of returning the plaintext data key and the encrypted data key, what KMS does is it takes the encrypted data key and sends it to the XKS proxy that you have specified in KMS. The XKS proxy is assumed to authenticate and authorize the request, and if authentication and authorization is successful, send that package to a HSM, for example. This one uses a key that is stored in the HSM, can be Securosys HSM, to encrypt that key a second time. So we add another wrapping layer around it. And then that double encrypted key is returned to KMS, which returns it together with the plaintext data key, again, to the service. Service encrypts the data, throws away the plaintext data key, stores the encrypted data key together with the data. Now you can take a picture, now the slide is complete, on durable storage. In other words, what we do here is where it says send data key ciphertext in signed encryption request. So instead of taking the data key and encrypting with a key that is managed by KMS, we still do that. But you have the possibility to add another layer of encryption around it. And now you also see how this stop switch is actually working, because to decrypt the data, I need the data key. And to decrypt the data key, it's not sufficient to just use the key that is managed by KMS. If you cut, I think that there's no pointer. If you cut the connection to XKS proxy, or between the proxy and your HSM, the plaintext data key is not reachable and your data cannot be decrypted. And that's something that you can do immediately if you want to. I wouldn't recommend to do it, but you can. Now, how can you deploy that? And I remember there was a question on LinkedIn, a very specific one, about the installation and runtime of XKS Proxy. And I promise you will find the answer in this or the next slide. So there are multiple deployment options. Then there is something that is always in common, which is we need an XKS proxy. So again, here we start with an AWS service and we start with KMS. And now we have this small little box called external key store, which is a configuration in KMS that says, okay, for this key, I want to use this external one, this HSM that is under my control. Now, the difference is how we deploy or manage XKS proxy. And the simplest thing is you just run it on premise, or you just run it where your HSM is located. Connection to the XKS proxy happens, for example, over the internet, or would typically happen over the internet. And now you might wonder, yeah, but do I really want to expose an API that can talk to my HSM? Of course, there is authentication authorization built into the solution. A request between KMS and XKS proxy is always always authenticated and also authorized using a so-called SIGV4 signature. SIGV4, in just 2 sentences, is a protocol that we use at AWS in every service to authenticate and authorize requests. So it's basically a request signing algorithm that allows, based on zero trust principles, to authenticate and authorize on a per request basis. We don't even need a session. You can also use MTLS for this connectivity if you want to, but SIGV4 is always mandatory. So even if you use MTLS, you will get a SIGV4 signature on the request. The second option, and we start with the same elements here. We start with an AWS service, we start with KMS, with configuration of external key store. But now my external key manager is the only thing that runs outside of AWS. And we use so-called VPC endpoints here in this setup. VPC endpoint service, again, a little bit simplified. It's an internal routing service that ensures high availability and authorization within AWS. So you get high availability built in. The first thing you would do here is to create a so-called VPC or virtual private cloud, which is basically a network in the cloud, in 2 different availability zones. An availability zone is always at least 1 data center, and I had a few conversations. In Switzerland, we have 3 availability zones, and they are as far as possible apart from each other, but always max 100 kilometers so that we can ensure the latency that we need for synchronous replication, for example. Now, in each of those subnets that we create in the availability zone, we can place an XKS proxy. And you see here we have high availability built in because the network load balancer, and this is really the name implies what it is. It's just a load balancer. And that load balancer will ensure high availability, including health checks, et cetera, et cetera. It's also where we can enforce authorization. So resource-based policies, which is a type of policy that controls who or what can access this proxy, are enforced there. And then the connection to your HSM can actually be anything from the so-called network to VPC network connectivity options, like direct connect, which is really get a physical cable, site-to-site VPN, client VPN, SD-WAN solutions, or if you prefer, but you probably won't, public internet. And there's a third option that you have, and I will just very, very briefly talk about that, because typically customers choose one of the first 2. VPC endpoint services can also have endpoints that sit outside of AWS, and this is exactly what this is. You will place XKS proxy outside of AWS, and then just do some basically kind of a virtual routing. The only advantage actually of this one is that you get an endpoint policy on the load balancer. Besides that, it doesn't offer too many advantages. I just saw I'm running out of time, so let's briefly talk about monitoring because this is important. You can find various XKS metrics in CloudWatch, so like availability, latency, errors, but also things like when are certificates expiring, because we use TLS. Certificate expiry is always something we should keep an eye on. And these metrics are actually important, not the certificate expiry, that's also important, but latency is. Why? Because XKS comes with latency requirements. And the reason is, I mentioned a couple of times, we want you to be able to use it transparently, seamless. But that also means we need to reduce risks for downstream impacts. So important figures include, we need a ping latency of no more than 35 milliseconds. That's nice, but the important one is yet to come. Connection timeout, 250 milliseconds, and max round trip time, 500 milliseconds. And that's super important. If you want to take something from this talk, take the 500 milliseconds, please. This is absolutely critical because if the round trip time is more than 500 milliseconds, what will happen in KMS is it will throw away the data key and the operation will fail completely. Now, what can you do about it? Because this is a presentation, I shouldn't talk about problems, but I should talk about solutions, right? Well, watch for proximity. Don't use KMS in Switzerland and then use a HSM somewhere thousands of kilometers away. Or, pro tip, consider, for example, Cloud HSM by Securosys. Why? Because, first of all, and I was told yesterday, there are various clusters available. So in the US, in Singapore, in Europe Central, comes with fully redundant internet connectivity with an SLA of 99.9%. It's like a safe option to me. And if we take a step back and see how you can use Securosys XKS Proxy, because that's something you still need, there's also a solution for that. The QR code points to the public documentation on the Securosys website. It's a ready-to-go solution based on Docker images, and it works with on-premise HSM as well as Cloud HSM, so on the top right. And I checked the quick start guide. It's just 4 simple steps. Couldn't be too much easier, I would say. And again, it supports all the setup options that I talked about in a VPC, on-premise, using VPC endpoint services, etc., etc. If you still have questions, the good thing today is we have people from AWS here, that's me, and we have a lot of experts from Securosys here. So feel free to ask questions, talk to us. We're happy to help. Thank you very much.